Good morning, students. Once again, I welcome you to my video lectures on control systems, and at present, I am handling time domain analysis chapter. So, yesterday, I went through what is time domain analysis and what are the two important aspects of time domain analysis and uh, the the solution the solution, that is the steady state error as well as speed of response, are going to be assessed in time domain, and I have explained those points in the previous class. Now the topic for today is what is known as typical test signals. Typical test signals which are used in time domain analysis of control system. I will explain typical test signals. So before I go through typical test signals, what is the importance of typical test signals in time domain analysis? Now, in electrical circuits and communication circuits, the inputs are known. So the input may be sinusoidal input, it may be a triangular input, or it may be square input, or it may be trapezoidal input. So input is known, and the constants and the circuit is also known, and you can assess the performance of the circuit. Whereas in control systems, in practical control systems, sometimes the inputs are not known ahead of time. To understand this, I'll give the example of uh, Warfield application, that is tracking using the radar tracking system. As you know that in wars we have to track the enemy aircraft which will be flying at a greater height and with a greater speed, and we have to track the enemy aircraft, and then after pinpointing or the target, then we have by firing the missile we have to destroy it, is it not? That is what radar tracking system. In warfield, what happens, the the enemy aircraft will be moving, and will be continuously changing its position and speed. For such a system, the radar tracking system, input is in the form of the enemy aircraft position as well as speed. You can't predict it. It will be continuously changing. When it is not possible to predict its position and speed, how can we design the system? So a designer, if he has to build the system, he cannot assess the performance of such a system, and when input is continuously changing. So to assess the performance of such systems, so in time domain analysis, there are few signals which are listed. By taking these inputs, we will going to assess the performance, and the performance may match to the practical application, and that is why we have to go through what are known as typical test signals. So by using test signals, performance is assessed. So what are these typical test signals? The typical test signals are three in number. Number one, step input, step signal, step signal. Number two, ramp signal, and the third one is what is known as parabolic signal, parabolic signal. Now I will explain step signal. So step signal is written as RT is equal to AUT. ART is equal to AUT. In the network analysis, you have come across step signal. So how will be step signal? Step signal is assessed like, is sketched like this. This is T, RT. This is what is called as step signal. For T less than 0, RT is 0. For T less than 0, RT equals 0. And for T greater than or equal to 0, RT equal to A. For T less than 0, this is origin, the functional value is 0. Whereas for T greater than or equal to 0, its value is A. So this is what is called as step signal, and the value remains constant at A forever. So what is step signal? Step signal can be think of as a disturbance. Why it is called as a disturbance? Because there is a sudden change in the level from 0 to A. So sometimes systems are acted upon by disturbances which act instantaneously. So immediately it is changing from 0 level to A level. Now the system, the control system should respond to such disturbances. So that is why the usefulness of step signal lies. So a step signal is the basic signal, test signal, which is used in time domain analysis. So this is what is called as step signal. Now the next signal is what is called as ramp. Ramp signal is a continuously changing. What is the difference between step and ramp? In the case of step, once the disturbance occurs, then its level remains same. But in a ramp, the input keeps on changing. So this is what is called as a ramp signal. A ramp signal it is sketched like for t less than 0, for t less than 0, its value is 0. Its value is 0. And for t greater than or equal to 0, RT value is equal to AUT. AUT, where this A represents the slope of this inclined line. Slope A. Slope A. You know what is slope? Slope is opposite side by adjacent side. Imagining a right angle triangle. Now, if A bears one value of unity, then it is called as unit ramp. Otherwise, it is a non-unit ramp. So, a ramp signal is given by RT is equal to AUT, where A is the slope value. If it is 1, it is called as unit ramp. Now, in this signal, it keeps on changing as you can observe. It is keeps on changing, and this is also a useful signal. So what is called as a ramp signal. So for a ramp signal, it is RT is equal to ATUT. Sorry, I have missed T. So it is ATUT. It is not simply AUT. It is ATUT. RT equal to ATUT. ATUT. For t less than 0, 0. RT equal to 0. For t greater than or equal to 0, its value is AT. For t greater than or equal to 0, its value is AT. Because UT value is 1, unity. So this is what is called as ramp signal. Now, next is parabolic signal. Now this parabolic signal is faster than ramp signal. Why it is faster? It keeps on changing fast in a fast manner than ramp. So what is parabolic? So you are all familiar with the parabolic graph. Parabolic. This is not an inclined line like this. It is taking a bend, and the changes are faster compared to ramp signal. So this is what is called as parabolic signal. A parabolic signal is given by t square ut. In the case of ramp, it was simply tut. Now t square ut. So you can see the degree of t. In the case of ramp, it was unity, tut simply. Now it is t square. It is greater than that of the power of t is greater than that of ramp. Therefore, the changes are faster in nature. So RT is equal to t square ut. And its value, RT value is 0 for t less than 0, and its value is equal to t square for t greater than or equal to 0. That is when t is positive. When t is positive, its value is t square. Whereas when t is negative, this side, its value is 0. This is what is called as parabolic input. So in control systems, in practical applications, before designing the system, the design engineer is going to assume these signals, and he will assess the performance of the system subjected to these inputs. And it gives him an idea in designing the system, and these signals are very useful. Now in this chapter, I will take up these signals only for not for all the order of system. Only for first order system, I will consider step, ramp, parabolic. Whereas for second order and higher, I will consider only step signal. Okay. With this explanation, I will end the class. Thank you.